Welcome to our introduction to the application load balancer. In this video, we will introduce the second type of load balancer under the Elastic Load Balancing service, which is the application load balancer. My name is Seth, and I've been with AWS for over 5 years. I'm currently working as a technical trainer responsible for delivering trainings to customers using Amazon Web Services. Our agenda for this video is to first overview the application load balancer and introduce to you some of the major features included in this service. After that, we will discuss some of the usage scenarios where you could use the application load balancer. Lastly, we will go through a short demonstration of the load balancer itself. Starting off, what is the load balancer? The application load balancer is, as stated earlier, the second type of load balancer introduced as part of the Elastic Load Balancing service. While it still offers most of the features provided by the classic load balancer, it adds some important features and enhancements that lend it to unique use cases. At a quick look, some of the newly enhanced features include additional supported request protocols, enhanced metrics and access logs, and more target health checks. Some of the additional features for the application load balancer are the ability to enable additional routing mechanisms for your requests using path or host-based routing, native IPv6 support in a VPC, AWS Web Application Firewall integration, and more. There is a vast number of scenarios in which you would use the application load balancer. One is the ability to use containers to host your microservices and route to those applications from a single load balancer. Application Load Balancer allows you to route different requests to the same instance, but differ the path based on the port. If you have different containers listening on various ports, you can set up routing rules to distribute traffic to only the desired backend application. There are some new terms to learn when looking at the Application Load Balancer. While listeners are essentially the same, you can now group the destinations or targets into target groups. Because the application load balancer registers targets instead of instances, a target group is how the targets are registered to the load balancer. Here, we can see how the application load balancer routes and organizes backend targets. When configuring the listeners for the load balancer, you create rules in order to direct how the requests received by the load balancer will be routed to the backend targets. To register those targets to the load balancer and configure the health check the load balancer will use for the targets, you create target groups. As we see here, targets can also be members of multiple target groups. As stated earlier, the application load balancer includes both enhanced and added features. The application load balancer has enhanced the supported protocols by adding HTTP 2 and WebSocket support. Additionally, monitoring capabilities have been increased by adding metric dimensions, performing more granular health checks, and additional details in the access logs. Some of the added features now supported are path and host-based routing. Path-based routing allows you to create rules to route to target groups based on the URL in the request. Host-based routing enables the ability to have multiple domains supported by the same load balancer and route requests to target groups based on the domain requested. In addition to that, you gain the ability to use request tracing to track requests from clients to targets, and the ability to enable dynamic host ports when using EC2 container services scheduled containers. So now we'll look at a quick demonstration of the application load balancer. We'll start in the AWS Management Console, and to create a load balancer, we will go to the EC2 console. So once in the EC2 console, you'll see that I already have 2 instances running. I launched these instances so that we would not have to wait for them to start while we were going through this demo. To test and see what I have set up, let's look at the application ELB test instance that I have created. When looking at this instance, we will show that I have 2 containers listening on 2 different ports. So to do that, we will copy the public IP address for the instance, and then in a web browser tab, we will go to the pages that I have set up for the demonstration. The first page is just listening on port 80, and it is test.html. If we go to that site, we'll see that container 1 is working. If we want to see the other port that I have listening, we'll go to port 443 and go to the same page location. And then that will show that we have the second container up and running. So now that we've done that, let's go ahead and create our application load balancer. To do that, in the side navigation pane, we will go to Load Balancers. You will currently see that I have no load balancers created. So to create an application load balancer, first I will click Create Load Balancer, and then I will let the default selection remain, which is Application Load Balancer. After that, I will click Continue, and this is where I start to configure the load balancer. So first, we will name our load balancer. Keep in mind that the name that we put here will go into the DNS endpoint for this load balancer. So I will name this ALB for Application Load Balancer and Test. This will be an internet-facing load balancer, meaning that it will have a publicly referenceable DNS endpoint. And I will leave the address type as default, which is IPv4. For the listeners on the load balancer, the default setting already has it listening for port 80, but so that I can route to the second container from the same load balancer, I will add an additional listener, and that will just be a simple HTTP request to port 443. After that, the load balancer wants us to select the availability zones that we will be running in. With the application load balancer, it requires you to select at least 2 availability zones. So I will select the VPC that I've created for this demonstration, and then select the 2 availability zones that I have created subnets into. After that, we have the option to tag our load balancer. To tag the load balancer, you simply just state the key and value for which you would reference this load balancer. For the one that we're building here, I will set the key to name, and then I will set the value to application load balancer. After that, we can configure the security settings. On this page, we would configure the security settings if we were using an SSL listener. Since we are not, we will go ahead and go to the next page where we configure the security group. For the load balancer, I am going to deselect the default security group and select the test web server security group that I have set up for this load balancer. After that, we can move forward and configure the routing. This is going to allow you to configure a routing rule for the backend destination for your load balancer. So to do this, because I have not pre-created any target groups, I will go ahead and keep the new target group set, and then I will name the target group. This target group will be named Demo1. The protocol that it's using is HTTP, and the port is going to be to 80. For the health check, it's going to stay an HTTP request, and the health check destination is going to be the simple web page that we have set up, which is test.html. We can also go into advanced health check settings, and this is where we can adjust how we want the health check to be done. In order to make sure that our target is healthy at an earlier time, I'm going to lower the health check interval to every 10 seconds, but I'm going to keep the timeout and the healthy and unhealthy thresholds the same. After that, we start to register our targets. Registering the target is telling the load balancer what instance you want that port to be hit. So I have the instances set up here, and I will go ahead and select the application ELB test instance that has been set up. After I select that instance, I click Add to Registered, and you will see that the instance is listed as one of the registered targets. Moving forward, we get to our review page. On the review page, we see everything that we have configured. It's showing the load balancer's name, it's showing the listeners and the routing rules that we have set up, and it is showing the new target group that we have set up with Demo 1. After that, we can go ahead and click Create. We see that our load balancer has successfully been created, so we'll close the screen and it will take us to the load balancer dashboard. Because we have two targets that we want to check with this load balancer, in order to register the second target, we must first create a target group. So, to do this, under Target Group, we will select Create Target Group, and this new target group is going to go to the second container that we have set up. So the target group name for this will be Demo 2, and it's going to be an HTTP request, but it's going to be forwarding requests to port 443. It's going to be in the same VPC, and our health check is going to be the same target but in the separate container. So it's going to be test.html. Under the advanced health check settings, we again have the options to adjust our health check, and again I will lower the interval to every 10 seconds. After that, I can create the target group, and it shows that I have successfully created my second target group. With that second target group, I then have to make sure that I have registered the instance as a target for that target group. Because it's done, I can now go over to my load balancer and verify that I have both ports set up for the listening on the load balancer, but because I set up 443 when I was creating the load balancer, it is currently forwarding it to Demo 1. In order to change that, I will click View and Edit Rules, and under the Then, instead of forwarding it to Demo 1, I will edit and edit this rule that I have created and forward it to Demo 2. Once I've done that, I click Update, and the rule to route traffic hitting port 443 on the load balancer is now forwarding to the target group Demo 2. I can now go back and view the load balancer. Now that we have created our second target group and registered it to the load balancer, we can test to verify that our traffic is being sent to each container. To do that, we will again copy the DNS name, and then in a new tab, for the first container, we will paste the DNS name and we will go to the target that we have set up for the demonstration, which is test.html. And we can see that container 1 is available. To test the second container, we have the load balancer listening on port 443, so we will set it to go to port 443, which should forward traffic to 443 on the instance where container 2 is listening. If we hit enter, we can see that container 2 is now up and running. If we would like to adjust the listening for the load balancer, we can always go to the Listeners tab and add or edit the listeners that we have running. In review, this demonstration covered launching an application load balancers, configuring the routing rules, registering the targets to the load balancer, and then verifying the operation of the application load balancer's routing.